Today's lesson is a fairly straightforward one because we're just going to go over some past concepts like linear systems, which means a straight line when you graph it, quadratic systems, which is a parabola when you graph it, and where their point of intersection is. So where those two graphs meet. So as long as you have your basic algebra skills that we've talked about most of the year so far, then you'll be fine. So when we talk about points of intersection, if there's two of them between a parabola and a straight line, this is what your graphs could look like. So if I graph two equations, they could look like this. I have a straight line and a parabola, and they meet at two different points. So there's 2 points of intersection. There's one right there and one right there. So there would be ordered pairs in which those points occur at. So a way that there might only be one point of intersection is if I had a parabola, and it might open up or down, it would work the same way, and a straight line that crosses right through its vertex. So the vertex there would be the point of intersection. Last but not least, it's possible to have no points of intersection as well. So if we had a graph there that opened down and a straight line that was above it, vertically above it, that it didn't slant at all and meet somewhere out of sight, there would be no points of intersection. Now that we have an idea of what the graphs would look like for 2, 1, and 0 points of intersection, let's actually find what they are for our two equations here. You can see for our first function here, that's linear, it has a degree of 1. And our second function here is a quadratic, it has a degree of 2. So if we make those two equal to each other, because our points of intersection, that's exactly it. It's where both equations have the exact same solutions. So if we make them equal to each other, and then we do basic algebra, we can come up with our roots, our solutions, quite easily. So I'm going to bring everything to the right side. So I have x squared. Sorry, I forgot my x there next to that 10. So if I have plus 10x minus 8x minus 6 minus 9. That step you may not need anymore. I'm just being sure that we show everything so we don't lose anybody along the way. So I now have an equation of x squared minus 2x minus 15. In order to find what the solutions are, I can factor this equation. It's a trinomial. I just need to find magic numbers that work. So I have x minus, oh, that's supposed to be a positive 2. Let's look back here. That there is a positive 2. So it's really important that we see that that sign is positive 2 because it changes our magic numbers. Our magic numbers there are x plus 5 and x minus 3. Because 5 times negative 3 is negative 15, and 5 plus negative 3 is positive 2. So that means that my points of intersection are going to happen at negative 5 and at positive 3. But it's really important that we come up with the ordered pair where that point occurs. So we're going to have to take our x values, both of them, and substitute them into either or of our original equations. I find substituting into our linear equation easiest because there's the least amount to it. I don't have to worry about the exponent. So x plus 8x plus 9. So I have 8 times negative 5 plus 9. So this equals negative 40 plus 9, which is negative 31. So my first point of intersection happens at negative 5 and negative 31 on my graph for these two equations. And then I do the exact same thing for my number 3. So I have 8 times 3 plus 9, which gives me 24 plus 9, which is 33. So my second point of intersection, and it's important to answer this, this is what the question is asking, what is the point of intersection, happens at 3 and 33. All right, let's look at two more equations, and it says find the point or points of intersection. So the first thing we're always going to do is make them equal to each other, because what we want to find out is where our linear equation is equal to the quadratic, where their x and y values are the same. So I'm going to move everything to the left side, showing some of the steps of the algebra. I've looked to see if I can factor this, and I can't. There are not two numbers that multiply to be positive 2 and add to be positive 1. So this can't be factored. So this means one of two things. There are no solutions to this, there's no points of intersection, or that those points of intersections happen at decimals. So I would have to try the quadratic formula. Before I get into all of that work of the quadratic formula, I remember our discriminant from the other day, so I quickly use it to see whether there are any solutions or not before I get into the whole quadratic formula. I quickly see here that I have a negative answer, so I know that there are no points of intersection for this question, so I'm done there. Okay, our last example for today, and it says, how many solutions does the following system have? So it's nice to read that question carefully, because I don't need to know what the solutions actually are. I just need to know how many there are. So I started the same way, that I make them equal to each other, because it's the same concept. Just fix that little mistake there, and then we continue. 5x minus 3 is equal to negative 7x minus 12. So what we have here is 4x squared plus 12x plus 9. So again here, one of two things. I can factor this, or I can use my discriminant to find out how many solutions there are. A good thing to realize is, remembering your factoring, that here I have a perfect square trinomial. Remember that if you square root the first term and the last term and multiply it by 2 and it equals b, then you can factor it really easily by going 2x plus 3 squared. So our solution only has 1. Our solution, not that we need it, but our solution here is negative 3 over 2. So when x is negative 3 over 2, you have a point of intersection. So therefore, you have 1 point of intersection in this question. It would have worked as well in the same. You could have used your discriminant here. B squared, which is 12 squared minus 4 times 9. I just found it a little bit easier and faster knowing the perfect square trinomial to factor it. Both ways will get you to the same answer.